Hi, I'm Alexandra DeLucia. I'm a fourth-year PhD student working with Mark Judzi. Something wrong? Oh, good. Awesome. Yeah, fourth-year PhD student working with Mark Judzi. Today, I will be talking about Bernice, a multilingual pre-trained encoder for Twitter. I'm excited to talk about this project today because we just got the good news that it was accepted to EMNLP. And this was a fun project that was a big group effort with a handful of us in Mark's lab. We have Shijay, who just graduated, Aaron Mueller, Carlos, who's here, Mark, and also Philip Resnick, professor from UMD. So introducing Bernice. Bernice is a custom Twitter model. It's a pre-trained encoder for tweets. It's multilingual. It has a custom tokenizer that was trained specifically for representing tweets. And it was trained on a lot of data, 2.5 billion tweets. And Bernice is named by Mark. He is very pleased with this name. He named it after Bert's pet pigeon. So really keeping with that Sesame Street theme, even this one's very, very niche. So Bernice is a customized Twitter model. Why do we need a custom Twitter model? As many of us know, language models are widely used for representing text in our downstream tasks. Models trained on in-domain data perform much better than those trained on out-of-domain data. So you always want to train on the data that you're going to be, type of data you're going to be using later on in your process. Twitter is a very common domain for NLP research. About 300 papers alone are just from Mark's group. And Twitter is very common for sentiment analysis, mental health, predicting mental health disorders or things like depression, also the tracking of diseases. And Twitter itself is a different kind of language in itself. It has a lot of slang, a lot of different symbols that you don't see in other more formal text. And also there was a very big need in the field for this. So there were no from scratch multilingual Twitter models. I have a little symbol there because as I will talk about later, this was at the time of submission. So if you guys are like, wait, I know a model, just hold that thought. So there are existing models out there that people have used to represent tweets. One of the more common ones is BurTweet. So this one came out in 2020. I've used it. Great model. Awesome that they released it. It is a custom Twitter model for English tweets only. So it's really cool that they have a tokenizer specifically for tweets, trained on just a ton of English tweets, not multilingual. Other models that people use that are more multilingual would be XLMR, which is trained on all of Common Crawl, which is a considerable amount of data. Although using XLMR, it does not have a tokenizer specific for tweets. XLMT is relatively new. It is a model with a second pre-training on multilingual tweets. It starts from XLMR and then continues on to train on about 200 million multilingual tweets. So this is really great. Got to see a lot of tweets, but is still using that original XLMR tokenizer. And then lastly, we have Bernice. So Bernice is also a Roberta architecture, and it's trained on 2.5 billion multilingual tweets. We have a Twitter tokenizer, and it is multilingual. The two models that I'm going to be comparing to more frequently in this presentation and when evaluating Bernice are XLMR and XLMT. These are very important comparisons because we get to evaluate the effect of completely training on in-domain data versus like the secondary pre-training that XLMT does, and also the fact of whether or not having a custom tokenizer for tweets makes a difference versus just seeing a lot more data. So I'm going to go over the architecture and training of Bernice. Bernice is a Roberta base model, so it's based on BERT base architecture. but uses the Roberta pre-training objective, the mass language model objective. We also chose a smaller input sequence. So typically it's about 512 subword tokens in BERT. And then other models are even larger, like 1024 tokens. But for Bernice, we chose 128 max subword tokens, and the output, same as BERT base, 768 dimensions. For our training data, we use 2.5 billion tweets. This covers 5 years of the Twitter 1% public stream from January 2016 to December 2021. This is about 30 billion tokens, and it covers 66 languages. So this 66 languages is as defined by the Twitter metadata. So Twitter has its own language identification system. I'm not familiar with what exactly model they use because they have a lot of in-house stuff.
Last time, what does input packing?
Oh, input packing. So instead of feeding each individual like tweet or sentence and like news articles and stuff into the model one by one, as an example, you would just fill the entire input sequence. So it was kind of, we ran like an ablation on this. It was a little odd that input packing was helping in training, like lowering perplexity and loss and stuff. But it did show that, because unlike sentences in news article, tweets are like completely different thoughts as opposed to having the same context. But it was helping the model, so we went through with the input packing.
Thank you. So your point to that detail is that these are randomized. These are not a sequence of tweets from a person or tweets and responses. They were just completely random.
Yep. Yeah, so 66 languages as identified by Twitter, but this also includes an undefined tag where it could be maybe like there's, I guess the Twitter language identification system wasn't super confident in the language. Yes, so this other people said they found like hundreds of languages on Twitter, but you have to go through other language identification systems to find those languages. So we refer to this data set as the pre-sampled data set. For all the tweets, the top languages would be like what you would expect, high resource languages: English, Spanish, Portuguese, Japanese, Arabic. And then all the way on the right side, we have the lower resource languages: Tibetan, Central Kurdish, Pashto, etc. So a concern we had with this model was we wanted to make sure that we were able to represent these low resource languages well. A common method when training a multilingual model is using exponential resampling of the data based on language. So you can do this during training or on the fly. As you're showing examples to the model, you can randomly choose what language you want or what example you want the model to see based on language. Or you can show the model a data set that is already sampled by language. But this would be like a static set that does not change during training. For Bernice, we use a combination of both. So for this language sampled data set, yes, so this ensures that the model sees the less prevalent languages. The low resource upsampling is controlled by the parameter alpha, where the smaller the alpha, the more upsampling of low resource languages and downsampling of high resource languages. We use an alpha of 0.5. This is one that was also used for XLMR. Other common alphas would be 0.3, 0.5, and 0.7. So for our tokenizer, we used a sentence piece model. We trained it on the language sample data set. So we want the tokenizer to have good coverage of all languages on Twitter. We used a shuffled sample from each month of our data set. This is to make sure that our model isn't like too biased towards one time period, although it does only see data from 2016 through 2021. Also, we use a vocabulary size of 250,000. This is a standard size for multilingual models, same size as the XLMR. /XLMT tokenizer and MT5. We also tried to evaluate our tokenizer coverage. So we compared our tokenizer trained on tweets to the one from XLMR, which was trained on Common Crawl. We found that our tokenizer has better coverage, which would mean that our tokenizer needs less subwords to represent a tweet on average versus the XLMR tokenizer. And also on average, our subwords are longer. So in general, this means that our tokenizer has better coverage, which has been shown to have better downstream task performance. So just to recap our Twitter-specific design decisions for Bernice, tweets are short, so we use a... Yes.
So how much of this do you think was because of your language resampling? What I'm thinking is that otherwise the languages that dominate the data would drive it, and you might need fewer pieces to cover things. So maybe use more language. Is that why you're getting?
Oh, why we have longer subwords and stuff? Maybe because Bernice does cover, so the XLMR tokenizer and XLMT was trained on Common Crawl. So Common Crawl does have 100 languages identified. So when they do their exponential resampling, it is taking into account more languages as opposed to our tokenizer, which the undefined tag was just one bin with upsampling. But
yeah, I'm just trying to figure out the root cause of these numbers, and I first thought it might be a resampling, but I'm not sure. Hey, if you could think about why, because I'm assuming you didn't change the algorithm for it.
No, we didn't change the sampling algorithm. Yeah, but we did have less languages. And so, yeah, as of now, we are assuming that this is because the data is more fits the tokenizer. The tokenizer is actually trained on tweets. Yeah. Emojis are characters. Yeah, there's other, so for the Burr tweet, the English Twitter model, they do like this, they use an emoji package to like translate the emojis into like a word. Yeah, we didn't do that. We just kept it as a symbol. I can check what it's doing for the emojis for the, I mean, if there's a lot of emojis that happen together.
I'm just curious because I was definitely explaining some of this and that, like, I guarantee emojis are separate.
Yeah.
So like if you have emoji strings that are really common, they're all going to be split up.
Yeah.
Or is it for these, like the two always closer next to each other, or often do, for example, like throwing two laughing faces around? That's not something. So it'll probably think that.
Okay, yeah, no, that's a good idea, checking for, so something that we're gonna add for the camera ready are different experiments with just looking at tokenizer coverage and stuff, and how much like better or worse our tokenizer does at representing certain things. So looking specifically how it represents the emojis would be good. Yes, so Twitter specific design decisions, tweets are short, we use a shorter input sequence length, 128 max subwords. Twitter is popular around the world. We want a model to be multilingual to be able to represent more populations that use Twitter. Code switching or switching between languages in a single sentence is extremely common. So our tokenizer being multilingual is also very good. Also, the language on Twitter is a bit different from other formal texts, such as news articles, Wikipedia, medical data, etc. So we use a tokenizer trained specifically for tweets. For the actual training, we did about 150 steps on the language-sampled data set. This is the one that was a static data set where there's no sampling on the fly, where the low resource languages are upsampled, high resource languages are downsampled. So this ensures that the model is definitely seeing a significant amount of these low resource languages. And then we switched to the pre-sampled data set where it's doing more on the fly sampling by language. So we trained to a total of about 400,000 steps. Training took about 200 hours. So for model evaluation, we wanted to see, did our design decisions matter? We evaluate Bernice on 3, yeah? I think it was like 4. Yeah, double check that number. Yes, so evaluation. We evaluated Bernice on 3 different Twitter benchmarks. And we also compared to 2 other models, the XLMR, which has no Twitter pre-training at all, and XLMT, which has a second pre-training on Twitter data, but it does not have this Twitter tokenizer. So in general, XLMT has seen significantly more data than Bernice because it's from the XLMR checkpoint. So it's seen like all of Common Crawl plus 200 million tweets, whereas our model has seen significantly more tweets, 2.5 billion tweets, but significantly less data overall. So our first benchmark is TweetEval. This is actually an English only benchmark, but we used it because it's a very popular benchmark. It's kind of, you need to evaluate your Twitter model on it. Otherwise, reviewers are going to be like, why isn't it here? It's a combination of about 7 tasks, including emoji prediction. So the bird tweet model is still state of the art, which makes sense because it was trained exclusively for English tweets. So it's going to do best on the English only benchmark. But we also see that XLMR is outperformed by XLMT and Bernice. So we see that the Twitter pre-training does matter. And also XLMT and Bernice are highly competitive. Bernice has seen less data than XLMT, but significantly more tweets. For our second benchmark, this is a multilingual one, the multilingual sentiment analysis. It's about 8 different monolingual sentiment analysis data sets. We see the same performance pattern that we saw on TweetEval, where Bernice and XLMT do better than XLMR that doesn't have the Twitter pre-training. And Bernice and XLMT perform very similarly, with Bernice just outperforming XLMT overall. And for the last benchmark, this is a multilingual hate speech benchmark. It made up of 9 monolingual. Yeah.
So each tweet has just one sentiment attached to it, or are there multiple in this task? I mean, are you performing?
I think it's like positive, negative. Carlos, you did this one, right? You did the hate speech.
So meaning what I'm thinking is whether it's just a K-way classification task, or is it one of those multi-label tasks?
No, it's not multi-label. It's definitely like positive, negative.
I see.
Possibly a neutral tag in there.
Okay, so a few classes of sentiment.
Yeah, yeah.
Got it.
Yeah, so with this hate speech one that Carlos did, we have the same trend performance as earlier. Bernice and XLMT are basically neck and neck. They perform very similarly, but both outperform XLMR. So the results summary from these evaluations, we show that models that have the in-domain data pre-training perform better than models that have not. XLMT and Bernice both perform XLMR. This is not a novel finding. We've already known this from other work. But what is interesting is that training completely on in-domain data is more efficient than domain adaptation. So XLMT started from XLMR, which has seen all of Common Crawl, and then about 200 million multilingual tweets. Even though XLMT has seen less in-domain data as Bernice, XLMT has seen significantly more data overall. So even if you add up the XLMR and XLMT pre-training, it does not compare to the amount of pre-training that Bernice has had. Much lower amount of pre-training, considerably less data. So some remaining questions are, how does Bernice perform on low resource languages. As you saw, the languages in these benchmarks are high resource: Arabic, Portuguese, French, etc. This is something that we are working on for our camera ready. Difficult to find low resource tweet benchmarks. So just some updates since June 2022, which was when the paper was submitted. Some things have changed. The field moves. Oh, yeah.
So for the low resource languages, what's out there? What could you do?
I have it.
Cool. Let's keep going.
Amazing question. Yeah, so we have some planned experiments for our camera ready. We want to evaluate performance on the low resource languages. We want to do more experiments with the tokenizer coverage analysis comparisons. And I did that. I had a little asterisk symbol saying at the time there were no multilingual from scratch Twitter models. Twitter just published one in September. So we're going to compare to that one called TwinBERT. So for low resource languages, we actually got a very good idea from one of our EMNLP reviewers. They suggested that we can compare the perplexity across languages on unseen data. Our model has only seen up to 2021, so we have all of 2022 data to evaluate our perplexity on. And also there is a low resource tweet data set, indigenous-tweets.com. Someone went through and they found users that tweet in indigenous languages. It covers a lot from very, so this top one was Basque. They have a data set listed with users that tweet in these low resource languages. So we're going to go through that and also evaluate on this data set. And for TwinBERT, preprint that came out in September out of Twitter, Twitter Heterogeneous Information Network. So this is a multilingual model trained on about 7 billion tweets. Something interesting that they do is they also incorporate a social network and engagement objective during training. It's going to be very interesting comparing Bernice to this model because although this model has seen significantly more tweets, about 3 times as much, 2.5 billion for Bernice compared to 7 billion for this model, they use the XLMR tokenizer instead of training one from scratch. So it's not a perfect ablation, but it's very interesting to see how much, even though this has significantly more data, how much that extra data has helped from using a tokenizer not specifically meant for Twitter. So in summary, Bernice is a multilingual Roberta model for Twitter, training from scratch on in-domain data. It's more efficient overall than secondary pre-training. And we have some more work to do for our camera ready, such as evaluating on low resource languages. Our model is currently hosted on Hugging Face. So if you want to go download it, play around with it, if you do stuff with tweets, go for it. If you have any questions, let me know. And the camera ready is not ready yet, but if you want to read the paper or you just want to talk to me about it, just come up to me after the talk, email me, whatever you guys want. So thank you.